Hi, I'm going to share some idea about modular operation. First, let's look at the components involved in division operation. Dividend, a number which is to be divided, written in numerator. Divisor, number which will be dividing dividend, written in denominator. Quotient, number which is the result of division, obtained after truncating decimal part. Remainder, number which is left after subtracting quotient multiplied by divisor from dividend or dividend modulo divisor. So the result of modulo operation is the remainder and can be defined as dividend mod divisor, that is equal to dividend minus quotient multiplied by divisor, and that is equal to remainder. So the following equations can be derived. Dividend by divisor, after truncating the decimal part we get the quotient, and dividend minus quotient multiplied by divisor is remainder, that can be written as dividend equal to quotient multiplied by divisor plus remainder. Finally, dividend mod divisor is remainder. Here the second and fourth equation have the same RHS. When we do modulo operation, the result, that is remainder, can be positive or negative. There are different variants of divisions, but most programming languages like Java, C++ follow truncated division, which is the sign of the remainder depends on the sign of the dividend. For example, minus 14 mod 5 is minus 4, minus 14 mod minus 5 is also minus 4, 14 mod minus 5 is 4. Here, the sign of the remainder depends only on the sign of the dividend, unlike in division operation, where negative sign cancels out if both operands are negative or result is negative if either one is negative and another is positive. One more observation is absolute value of remainder is always less than absolute value of divisor. Okay, why do we want to perform a modulus operation? One famous scenario is converting from a 24-hour time format to 12-hour time format. There are only 12 numbers in the clock phase, but it is used for fetching the time for an entire 24-hour day. To do that, 24 hours is separated into two 12-hour segments, AM and PM. Whenever the time overflows more than 12 hours, starting from 0, it enters into another segment, that is from AM to PM or PM to AM. So we can get time in 12-hour format after performing modulo 12 on 24-hour format value. In the 12-hour format, 0 value is represented with 12. For example, 15:30 in 24-hour format is 3:30 p.m. in 12-hour format, which can be obtained by performing modulo on 15 by 12, that is 15 mod 12 is 3. 12:30 in 24-hour format is 12:30 p.m. in 12-hour format. Again, 12 mod 12 is 0, but 12 is used instead of 0. So, modulo operation can be used in scenarios where we want to have numbers only in a certain range. For example, when we want numbers in range minus 4 to 4, we can perform modulo operation with number 5 or minus 5. Let's look at these examples. Results are always in the range minus 4 to 4. One observation here is when we perform modulo operation with a number m, the range is minus of absolute value of m minus 1 to absolute value of m minus 1, and its length is 2 into absolute value of m minus 1. Second scenario is in a circular array where after incrementing from the last element we go to the first element in the array. When we want to find the index of the array after incrementing the current index by m, where current index plus m is greater than or equal to size of the array, we need to perform a modulo operation on current index with size of the array. For example, in this array, current index points to number 6, that is index 1. When we increment the current index by 10, that is 1 plus 10 mod 8 is equal to 3, the updated index will be 3. Third scenario is to check whether a number is odd or even. For this we can perform the following check. Number mod 2 is not equal to 0. One observation here is we should not check whether number mod 2 is equal to 1 to check whether it is odd, because negative odd number mod 2 is minus 1. For example, 81 mod 2 is 1, 16 mod 2 is 0, but minus 9 mod 2 is minus 1. Let's see some properties of modulo operation. We can perform modulo operation many number of times, that is a mod n is equal to a mod n. A power x mod a is equal to 0 for all positive values of x. A into b power p minus 1 mod p is equal to a mod p, where p is a prime number. This is by Fermat's little theorem. Minus a mod n plus a mod n is equal to 0. Associative property. A plus B mod n is equal to A mod n plus B mod n mod n. A into B mod n is equal to A mod n into B mod n mod n. This is not the exhaustive list of properties about modulus. Let's see a compiler optimization done by the compiler. When modulo is done by a number which is a power of 2. X mod 2 power n can also be calculated as x and 2 power n minus 1. For example, 56 mod 16 is same as 56 and 15. Thanks. If you find this video valuable, you may share with others. If there are mistakes, please mention them in the comment section.